Dear students, today we are going to discuss the concept that is formation of differential equation. Now, whenever the function is given to you, by using that function we have to form a differential equation, and that can be obtained by eliminating arbitrary constants which are included in that functions. Now we will eliminate the arbitrary constants by taking the derivative of a function. Means if there are n arbitrary constants, then we have to differentiate the given function n times. Means suppose if there is only one constant, then we have to differentiate that function only once. And if there are two arbitrary constants, then we have to differentiate the given function two times. And after taking the derivative, the arbitrary constants will be automatically eliminated. And if it is not eliminated, then by replacement we can remove that constant. So according to the given function we have to follow the steps, but always remember we have to differentiate the given function as per the number of arbitrary constants included in that given function. Okay, now we will take some examples, and by which we will form the differential equation by using that given function. So we will solve the exercise number 8.2 from your textbook. So let us see. Now see, from the exercise 8.2 there is a question number 1 that obtain the differential equation by eliminating arbitrary constants. Now first function is given to you, that is y is equal to a into e raised to 3x plus b into e raised to minus 3x. Now in this function there are two constants a and b, and by eliminating both the constants we have to form the differential equation. So here in this case, first of all, if I write y is equal to a into e raised to 3x plus b into e raised to minus 3x. First of all, I have to differentiate this function with respect to x. Now here we require the second order derivative also, because there are two constants. So differentiate with respect to x. Okay, hence you will get dy by dx, that is equal to, now see here a is arbitrary constant, we have to differentiate e raised to 3x. Now all of you know that derivative of e raised to 3x is by chain rule, it is 3 times e raised to 3x. So we can write here 3a as it is into e raised to 3x, plus here b is constant and we have to take the derivative of e raised to minus 3x, it will be minus 3b e raised to minus 3x. Okay, so first order derivative is completed. Now again we will differentiate this with respect to x, because there are two constant, we have to differentiate this again. Okay, and now take the derivative again, hence you will get the second order derivative, that is d square y upon dx square. Left hand side will be d square y upon dx square is equal to, now what happens on the right hand side, we have to take the derivative of e raised to 3x, then it is 3 into 3, that is 9a e raised to 3x, and here minus 3b is constant, we have to take the derivative of e raised to minus 3x, so minus minus plus 9 times b e raised to minus 3x. Now after getting the second order derivative here, now try to remove the arbitrary constants by using either by using the given function or by first order derivative and by modifying the second order derivative. Now if you observe this carefully, then there is a 9 common, and if you take 9 common, then you will get in the bracket a into e raised to 3x plus b into e raised to minus 3x. So just by practice you can observe like this, and here you can replace this bracket by y. So by replacement here we get the differential equation, that is d square y upon dx square minus 9y is equal to 0, just by replacing this bracket as it is given to you, that is equal to y. So after completing the second order derivative, just you observe the second order derivative and try to modify the terms in it so that the arbitrary constant can be removed. So here it is possible to remove. So we replace that a into e raised to 3x plus b into e raised to minus 3x as y, and hence we get the differential equation after eliminating the arbitrary constants like this. Okay. Now see the another function that is given here, that is y is equal to c1 e raised to 3x plus c2 e raised to 2x. Now in this case also c1 and c2 are two constants, two arbitrary constants, and that's why we have to differentiate this function two times, means up to second order derivative we have to take the derivative of this function. But if you observe this, just by previous method, if you differentiate this, then see here y is equal to c1 e raised to 3x plus c2 e raised to 2x. So first order derivative is here, it is taken as dy by dx is equal to 3 into c1 e raised to 3x plus 2 times c2 e raised to 2x, and again by differentiating with respect to x we get d square y upon dx square is equal to 9 c1 e raised to 3x plus 4 c2 e raised to 2x. But if you observe this second order derivative, then here the replacement is not possible because there is no any common part which we can take the common part here, so that we can replace the term, and by replacing we get the required differential equation by eliminating arbitrary constant. It is not possible because here it is 9 times c1 e raised to 3x plus it is 4 times c2 e raised to 2x. So if you compare this with the first example that already we have discussed in this lecture, it is not possible to remove the constants c1 and c2 by replacement. Then we have to follow the another method. So this method is not applicable here. We have to differentiate this with respect to x up to second order derivative, no doubt, but if you keep this function as it is and if you differentiate it, then it is not possible here to replace the constants. So just now we will solve by another method. So let us see now. I will write here answer. First of all, given function is y is equal to c1 e raised to 3x plus c2 e raised to 2x. Now if you keep this as it is and if you differentiate this, then c1 and c2 cannot be removed. So what will be the method here? So before differentiating this, if you divide this, divide the equation, divide both sides by e raised to 2x. Why we divide both sides by e raised to 2x? So first of all, let us see the step. What will you get? So if you divide by e raised to 2x, means actually we have to multiply by e raised to minus 2x. Divide by e raised to 2x means multiply by e raised to minus 2x. Then what will you get? Y into e raised to minus 2x is equal to c1 as it is. Now e raised to 3x into e raised to minus 2x, that will be e raised to x, plus now if you multiply e raised to minus 2x by e raised to 2x, then it will be 1, and that's why we get only c2 here. Now see here, the c2 is only constant, only single constant remaining. So after differentiating, after this step, the c2 will be removed. Okay, so that is the technique. So we have to modify this given function by dividing both sides by e raised to 2x, so that c2 becomes only one constant, only single constant, and that single constant can be removed by taking the derivative. Okay, so differentiate. After this step you have to differentiate with respect to x. Now see the left hand side, y into e raised to minus 2x. So we have to use the u into v rule here. So that's why now y as it is, and derivative of e raised to minus 2x is minus 2e raised to minus 2x plus, now keep e raised to minus 2x as it is, into derivative of y is dy by dx. So see, this is the derivative of left hand side. Now come to the right hand side, there is c1 into e raised to x, c1 as it is, and derivative of e raised to x is e raised to x plus derivative of c2 is 0. So after taking the derivative, we remove the constant c2. So that is the technique. So that's why we divide both sides by e raised to 2x, because if you take the function as it is previously shown to you, it is not possible to remove the constants by replacement. So here, that's why we have divided both sides by e raised to 2x, so that c2 becomes a single constant and it can be removed by taking the derivative. Now if you observe this expression, then see here what we get. Rewrite this: minus 2y e raised to minus 2x plus e raised to minus 2x into dy by dx is equal to c1 into e raised to x. Now just you adjust this. If you multiply by e raised to 2x, so multiply both sides by e raised to 2x, then what will you get here? Here minus 2y, you will get minus 2y, because e raised to minus 2x into e raised to 2x, that is 1, plus here you will get dy by dx, and to the right hand side c1 into, now e raised to x into e raised to 2x, you will get e raised to 3x. Okay, so just you observe this. Just for the simplification we have taken this step. Okay, now again we have to differentiate this step with respect to x, because we need the second order derivative, no doubt. Okay, but before differentiating this, again we have to do, means what we have to do here, again we will divide both sides by e raised to 3x. That means you have to multiply by e raised to minus 3x. Why we do so? Because to remove this c1, we require to divide by e raised to 3x, because after that you will get c1 as a single constant. Okay, that's why we need to do this step. So what we get here, minus 2y into e raised to minus 3x plus e raised to minus 3x into dy by dx is equal to, again we get a single constant c1. Now we have to differentiate both sides with respect to x. So differentiate with respect to x. Now take the derivative of every term. Here it is minus 2 as it is, and we have to take the derivative of y into e raised to minus 3x. So y as it is, and derivative of e raised to minus 3x is minus 3 times e raised to minus 3x plus e raised to minus 3x as it is into derivative of y is dy by dx. So check this carefully. Then plus, to differentiate e raised to minus 3x into dy by dx, again we have to use the u into v rule. So that is, now e raised to minus 3x as it is into derivative of dy by dx, that is d square y upon dx square, plus now dy by dx as it is into derivative of e raised to minus 3x is minus 3 e raised to minus 3x. Okay, so left hand side's derivative is completed. For both the terms we require u into v rule, and to the right hand side that derivative of c1 will be 0 because it is a constant. So derivative is completed, means second order derivative is completed now. Also we have removed the constant c1 and c2. So procedure is completed now. So just you see the expression, that will be the differential equation. So multiply by minus 2 here. So it will be minus minus plus 2 into 3, that is 6. So 6y e raised to minus 3x minus 2 times e raised to minus 3x into dy by dx plus e raised to minus 3x into d square y upon dx square, see all the terms, and minus 3 e raised to minus 3x into dy by dx is equal to 0. So our procedure is completed. Just you simplify this differential equation. Now in this differential equation there is e raised to minus 3x common, so you can divide by e raised to minus 3x, so that you will get 6y minus 2 dy by dx plus d square y upon dx square minus 3 dy by dx is equal to 0. And now you can write this differential equation, that is d square y upon dx square minus 5 times dy by dx plus 6y is equal to 0. So this is the differential equation which is required to you after removing the arbitrary constant and after taking the derivative 2 times. Okay, so this is the detailed procedure. So see this carefully, okay, what we have done here, because by usual way it is not possible to eliminate the constant. So we modified the given equation so that we can remove the constant by differentiating both sides. Okay, if you have a single constant, then it is possible to remove, because by taking the derivative of the single constant, we know that derivative of single constant is 0. So that's why we modify the equation which is given to you, and then by adjustment we get the required differential equation. Okay, so this is the procedure to get the or to form the differential equation by eliminating arbitrary constant. Okay, thank you.